So today we'll be discussing projectile motion, and let's start with example number 2. So we have here a jumper. He jumps at an angle that is 20 degrees to the horizontal. Now his initial speed is 11.0 meters per second. Now here we have a question, letter A. How long does it take the jumper to reach the maximum height? Letter B, what is the maximum height? And letter C, how far does he jump? How long does it take the jumper to reach the maximum height? Now, in this case, what we will do is we first get the velocity along x and the velocity along y. So we have this given. So we compute first for the velocity along x. The velocity along x is just 11 cosine 20. And the velocity along y is 11 sine 20. So if you solve this, you will get 10.34. And you will get 3.76 here, meters per second. Okay, so we have now the x component and the y component. Okay, now the problem is asking how long does it take the jumper to reach the maximum height. So in that case, we have the following formulas. So let's check which is the most appropriate. We don't know any of the y's. Alam lang natin it's a maximum height, but the maximum height is not given. So we don't have this, we don't have this. We are left with this one. Now, let's check if all the given are present. Yes, this one is present. We've computed this, right? This one is, please remember that at a maximum height, at the time there, you always get, in a maximum height, you have a velocity of 0. So, in short, this is 0. And we are left with this one. We already know A, because A is just gravity. Negative 9.8 meters per second. So, let's use that formula. So, we know that this is at the maximum height. We already know the answer for that. And for this one, we already have this. So, let's look for the t. Now, let's just modify the values. So, we have this final formula. And then, we'll just substitute all the values. And then, we have the time. In short, when we reach a maximum height, it will be on 0.3 seconds. So, letter B, what is the maximum height? Now, we know the maximum time. We know that at maximum height, the velocity is 0. So, we've computed for this one and this one. Now, if you're looking for the maximum height, you can actually use these specialized formulas. This one came from this. Okay? Noting that the velocity at the top is 0. So, we have already shortcut formulas. Actually, we can use this one if you want to. So, let's just try. Y is equal to 1/2 times 9.8 times the one that we have. Hindi lang kita, but the time there is 0.384 seconds. So, let's just try. So, the answer here is 0.7225 meters. But if you prefer, you can always use this formula. So, let's just try if you use that one. We have this, and we also know the y, the v0y. We've computed that before in the start sa problem. We have, I think, 3.76 meters per second. Now, if you use that, we can modify it to this one, and then let's just substitute. We already know g, so if you substitute that, you will actually have almost the same answer. Okay? So that's letter B. Letter C. How far does he jump? Now, when you say how far, we are now talking about the range. Range. Now, or the change in x. We will now use this formula. Okay, I'll just write it down. Now, we know this. We've computed this before. That is 10.34. meters per second. And then, how about the time? Okay. The time is times 2 because we're talking about up, which is this time, but we have to go down. So, up and down, so you have to multiply this by 2 so that you will have a full range. So, if you compute that, you will have this answer. This is 7.94 meters.